Hello students, hope you are all doing well. Welcome to another video by Quick Study. Today our topic is properties of waves from GCSE Physics. So what are waves? Waves are disturbances that transfer energy from one place to another. There are basically four properties of waves, which are wavelength, frequency, amplitude and speed. Wavelength is the distance from one point to another in a wave. Frequency is the measure of how many waves are passing in 1 second. Amplitude, on the other hand, is the height of the wave, the highest extent that a wave can reach. The speed at which the waves travel to one place from another or to one medium to another is known as its wave speed. The formula for it is wave speed is equal to frequency multiplied by its wavelength. Let's look at the following figure. In this figure of a wave, we can see the highest extent is known as the amplitude, and the length between the points are known as wavelengths. There are 2 points, the crest and trough, which basically are both related to the amplitude, but one is positive, another is negative. There are mainly two types of waves. One is longitudinal waves, another is transverse wave. Longitudinal waves are particles of the medium. In longitudinal waves, particles of the medium move parallel to the direction of the wave propagation. Here in the figure, we can see that the wave is traveling in the same direction as the propagation. On the other hand, in transverse waves, particles of the medium move perpendicular to the direction of the wave propagation. These waves are characterized by crests, the highest points, and troughs, the lowest points. An example of a transverse wave can be visualized by a rope. If you move one end of a rope up and down, and waves travel along the rope with particles moving up and down while the waves move horizontally. Here in the figure, we can see how it is working. The boy is basically moving a rope. We can see its wavelength and amplitude, which are both categorized by crest and troughs. Along with the formula for wave speed, we need to know another formula, which is for the time period. The formula is time period is equal to 1 divided by frequency. Let's look at some math problems we will face while studying waves. In example 1, we have to calculate the period of a wave with a frequency of 200 Hertz. So we know T is equal to 1 by F. So it would be 1 divided by 200 Hertz. The answer would come out as 5 meter per second. In example 2, a tuning fork creates sound waves with a frequency of 170 Hz. If the speed of the sound in air is 340 meter per second, as we have studied before, calculate the wavelength of the sound waves. So the formula is V is equal to F multiplied by lambda, which is the wavelength. So lambda would be equal to V divided by F as to the triangle method. So the answer would be 340 divided by 170, which would come out as 2 meters. Waves also exhibit some interesting behaviors. Among them, the well-known are reflection and refraction. Reflection occurs when a wave bounces off a surface and changes direction. This is a common phenomenon which occurs with all types of waves, including sound waves, water waves, and light waves. There is a law of reflection, which states that the angle of incidence will be equal to the angle of reflection. We will get onto that later on. A fine example of reflection would be seeing ourselves into the mirror. When a light wave hits the mirror, they reflect, allowing us to see ourselves. If we point a flashlight in a mirror, we would see that the angle of incidence, which is the angle which we are pointing the flashlight, would be equal to the angle that is being reflected inside the mirror. We should know how to draw a diagram of reflection. Here in this figure, we can see a normal, which is at the center. This is where everything is drawn. We can see the wavefronts approach the barrier and create an angle of incidence. And then we can see the direction of the wavefronts after the reflection, which creates the angle of reflection. Notice that both the angle of incidence and the angle of reflection are equal here, as the law suggests that angle of incidence will be equal to the angle of reflection. On the other hand, refraction occurs when waves pass from one medium to another and change its direction due to the change in speed. A fine example of this would be putting a pencil inside a jar. Place a pencil inside a glass of water and observe how it appears bent at the surface of the water due to refraction. In figure A, we can see that how the pencil is showing that it is bent. In figure B, it is explained how this happens. The pencil is actually straight, but we see that it is bent due to the refraction occurred inside the water. In accordance to reflection and refraction, another effect is commonly spoken about, which is the Doppler effect. The Doppler effect is the change of frequency or wavelength of a wave in relation to an observer moving relative to the source of the wave. Let's see a figure to understand it better. Here, a police car approaches the person. The pitch of the siren sounds higher. As it moves away, the pitch sounds lower. This is due to the Doppler effect. When the source of the wave moves towards the observer, the waves are compressed, leading to a higher frequency. It is called the blue shift if it was for light. When the source moves away, the waves are stretched, leading to a lower frequency. It is known as red shift if it was for light. That's all for today, students. So in this video, we have learned about properties of waves and the behaviors of waves. We have learned about reflection, refraction, and the Doppler effect. Stay with us to learn more about IGCSE Physics and other subjects as we post regularly on our channel. To learn more about our online tutoring service, do visit www.quickstudy.uk.